Today our topic is solving systems of linear equations by graphing. So our essential question is, how can I represent and solve relationships using systems of linear equations by graphing? So first off, let's review graphing. We did that in class, but let's also review it again here. Graph the following equation: y equals negative 1/2 x minus 8. This is in slope-intercept form, so it gives us our m and our b. Our m is negative 1/2. Our b is negative 8. Remember to take the signs with the numbers. Now remember b, that's your starting point. That goes on your y-axis. So we go to our y-axis, and we're going to count down 8. 1, 2, 3, 4, 5, 6, 7, 8, and put a point right there. After we plot that point, then we use our slope. Our slope, remember, is rise over run. So we're going to put that negative with the top number. We're going to go down 1 and up 2, or right 2. Excuse me. We can also flip that around, and instead of going down, we can go up, but then instead of going right, we can go left. So we have two movement options. Let's start with the down and right first. We can go down 1, right 2, down 1, right 2. That gives us 2 more points, which 3 points on a graph is pretty good, but we can get more if we flip to that up 1, left 2. So let's flip to up 1, left 2, up 1, left 2, and we can continue to go across the graph until we cover a good portion of our graph. So right there, that is the line y equals negative 1/2 x minus 8. Now let's cover the new stuff, systems of linear equations. 2 or more linear equations in the same variables. Solution to a system of linear equations is an ordered pair or a coordinate point, x, y. Make sure you get that written down on your paper. Find the solution by graphing. Find the ordered pair where those two lines meet. That's really what the solution is. It's where the two lines cross each other. So you need to graph both of these. For this line, we'll call this the blue line. Our slope is 2. Our y-intercept is 2. Remember, if we have a whole number as a slope, we can put it over 1. Start with your b on the y-axis. B is equal to 2, so we plot that point right there. Slope is 2 over 1. That means we can go up 2, right 1, or down 2, left 1. Now the key with systems and graphing is we need to plot as many points as possible on the graph. So we want to go up 2, right 1 as many times as possible. And then we want to go down 2, left 1 as many times as possible. And connect those points. So this is, actually it ended up being more the red line. For the next one, again, we need to identify our slope and our y-intercept. Slope is 4, y-intercept is 6. Put a 1 underneath our slope. Start with your y-intercept. Go to your y-axis, go to 6. Put a point there. And then for our slope, we can go up 4, right 1, or down 4, left 1. Again, we need to do as many points on the graph as possible. So go up 4, right 1. Then go down 4, left 1. And here, connect the points. And you should find that your two lines, here I have the red line and the black line, share a point. That point is right here. That is our solution. That is where those two lines cross each other. So down here in our solution blank, we need to write the coordinate point for that. That would be negative 2 on our x-axis and negative 2 on our y-axis. Right there and right there. Both of those are negative 2. All right. Again, we're going to do the same thing, but with two new equations. 3x plus y equals 5. Now, if you notice, that equation is not in our y equals form. It's not in slope-intercept form. So the first step for this is to change it. We need to make it y equals, which means we want to leave the y where it is and move this 3x. To move a positive 3x, we need to do a minus 3x. So we get y equals 5 minus 3x. Now we can identify our slope and our y-intercept. Remember, slope is always next to the x, so our slope is actually this negative 3, and our y-intercept is 5. So we can plot our y-intercept at 5, and then use that slope to find the next points. It's a whole number, not a fraction, so we need to make it a fraction by putting it over 1. Negative 3 over 1. Negative means we're going to go down. Positive 1 means we'll go right. Or we can go up and left. Remember, we can flip-flop. So let's start with down and right. Go down 3, right 1. Down 3, right 1. Continue that pattern. And then we can also go up 3, left 1. Remember, you want as many points on the graph as possible. For our second line, you should notice that this only has one variable, y equals negative 4. That is a special case line that is actually going to be a horizontal line through the point negative 4. So we go to y equals negative 4, right there. And then we just draw a horizontal line through that point. Now, our two lines, our red line and our blue line, do share a point. They cross right there, and that is going to be our solution. So, we need to write a coordinate point for that, x and y. On our x-axis, we're right here at 3. And on our y-axis, we're right there at negative 4. So our solution is 3, negative 4. Alright, if you flip over your paper, we just have one last little thing to cover here. Special cases. We do have special cases for systems of linear equations, because what if the two lines never cross each other? What happens then? Well, then the solution is no solution. If they don't cross, then they can't have a solution. Then, if they are the exact same line, the solution is infinite solutions. Because then they cross at every point on the line, which means they have multiple crossing points, which means multiple solutions. So we want to graph these equations and figure out what their solutions are. Alright, we have y equals 2x plus 4. Slope, y-intercept, we go up to 4 on our y-axis. Slope is 2 over 1, which means we're going to go up to right 1 or down to left 1. Remember, we want as many points on our graph as possible. The second equation here is not in y equals form. So first step is to change it to become y equals, which means we want to leave the y where it is, move this positive 4x with a minus 4x. We get negative 2y equals negative 8 minus 4x. And lastly, we need to get y all by itself, so we want to undo that times by negative 2 with a divide by negative 2. Y equals negative 8 divided by negative 2 is 4. Negative 4 divided by negative 2 is positive 2x. So our equation is y equals 4 plus 2x. Now our slope for this is going to be next to the x, which is 2. So our slope is going to be 2 over 1. So we can go up and right, down and left. Our y-intercept is this 4 right here. So we're going to go to 4. And then we're going to go up 2 over 1. Now if you notice, this is plotting the exact same line. The red line and the green line are both the same, because if you look, our first equation was y equals 2x plus 4, and our second equation was y equals 4 plus 2x. They're the same thing, just in a different order. The 2x and the 4 are flipped. So this would be infinite solutions. Lastly, we have two equations, y equals negative 1/3 x plus 5. So we start at that plus 5. That's our y-intercept. We go up to 5. Slope is negative 1/3, so we go down 1, right 3, or up 1, left 3. Again, we want to go and get as many points on our graph as possible. And then our second equation, if we manipulate it to make it y equals, we would get y equals negative 1/3 x minus 3. So we would start at the negative 3. We would use that same slope of down 1, right 3, or up 1, left 3. And we would get these two parallel lines. Remember, parallel lines have the same m. They have the same slope. So here, these lines are never going to cross, so they have no solution. Alright, that's all the notes I have for you today. Thank you for watching this video, and please subscribe to my YouTube channel.